In this video, we're going to talk about parametric equations and calculus. Now, if you will recall, a parametric set of equations is given this way. They're also called plane curves. X equals some kind of a function of t, and y equals another function of t. Now, it doesn't have to be t. That's just what I'm using. So we're going to do parametrics and calculus. All right, so how do you take the derivative of a parametric? Well, if we want to know like the slope of the tangent, we would need dy dx. You'll notice that y is not a function of x, nor is x a function of x, even it's a function of t. So what we end up doing is we say this is dy dt over dx dt. Just do this with implicit differentiation in a sense, all right? So that's just going to give us, in this particular case, it's going to be g prime of t over f prime of t. Now that looks pretty easy, and it really is. The issue comes when we need to take the second derivative. So if we need to take d squared y dx squared, we have got to take d dx of what we just had, all right? So d dx of dy dt over dx dt. Now, notation-wise, this can get kind of ugly. Let me do this with an example. That would probably be a better way to go. So here's our example, and we're going to work on that. I'm going to have x is equal to 2t minus pi sine t. Y is equal to 2 minus pi cosine t. So the first derivative, no big deal. dy dt, so dy dx is equal to dy dt, which is going to come up here over dx dt. Okay, so dy dt is minus pi times the derivative of cosine. That's minus pi times minus sine, so it's pi sine t. dx dt is 2 minus pi cosine t. So, not too big a deal, right? All right, now let's take the second derivative. So let's take d dx of this, pi sine t over 2 minus pi cosine t. If I'm going to take d dx of it, here's what I'm going to get. d dx of this quotient, I've got to use a quotient rule. So derivative of the numerator first, I'm going to get pi cosine t. But t is not the variable of choice, so I've got to take dt dx. Notice how that is opposite. It's a reciprocal of this. So just be aware of that. Got to multiply by 2 minus pi cosine t. And then I've got to take this as minus, and then the first one, so pi sine t times the derivative of the denominator. Derivative of 2 is 0. Derivative of minus pi cosine t is pi sine t, and that is got to be times dt dx. I did this one wrong, didn't I? Oh no, yeah, this is dt dx. Okay. And then So there's the derivative of the numerator. Then we've got to have the denominator squared. Okay, so it gets a little bit involved. Now there are some formulas for the second derivative, and you can feel free to use those if you'd like. You might notice that it would be, the derivative of dy dx and all that kind of stuff. But let's take a look at what ends up happening here. This is kind of cool how it works out. So pi times the cosine of t. I'm going to leave this dt dx outside. So in fact, let me do dt dx right here. All right, so this is equal to, so got pi cosine t and then times 2 minus pi cosine t. Then I've got minus pi squared sine squared. So minus pi squared sine squared of t, and I took the dt dx out in front. Here I've got 2 minus pi cosine t all squared. Well, let's look at that. If I want to talk about this in terms of dx dt instead of dt dx, I need to take the reciprocal and put it in the denominator. So I'm going to go dx dt. This works just like a fraction, strangely, because it's not actually a fraction, but it certainly works that way. This one is 2 pi cosine t, 2 pi cosine t, minus pi squared cosine squared t, so minus pi squared cosine squared t, and then minus pi squared sine squared t. So we're going to end up here having 2 pi cosine t, and then minus, notice this has a sine squared and cosine squared, and they're both negative, so if I factor pi squared out, I've got cosine squared of t plus sine squared of t, which is 1, okay? Down here, what is dx dt? Well, I know what dx dt is. I did that one already. It's 2 minus pi cosine t, so 2 minus pi cosine t, and then times 2 minus pi cosine t squared, so that is 2 minus pi cosine t cubed. So there's your second derivative. It looks like this. It's 2 pi cosine t minus pi squared all over 2 minus pi cosine t all cubed. So second derivative is a lot more challenging than the first derivative, but the first derivative can be used to get the second derivative. Well, let's look at another example and do some work with that. And this one doesn't have trig in it. So here is another example. Let's try to find horizontal and vertical tangents of this one. So we need to do the first derivative. We don't need to do the second derivative. So x is t squared minus t plus 2, and y equals t cubed minus 3t. So let's take the first derivative. So dy dx is equal to dy dt over dx dt. This is basically just a form of the chain rule. So dy dt is 3t squared minus 3. Dx dt is 2t minus 1. So what I've got is 3 times t squared minus 1 over 2t minus 1. Or if I factor, I've got 3 times t plus 1, t minus 1 over 2t minus 1. So horizontal tangents. Horizontal tangent, the derivative is going to give us our tangents. So horizontal tangent is where this is equal to 0. That would make the numerator 0. So we'd have t plus 1 is 0. That's t equals negative 1. And t minus 1 equals 0. That's at t equals 1. So these are both places where we've got horizontal tangents. Vertical tangent is where the denominator is 0, so 2t minus 1 is 0, or t is equal to a half. So we've got 2 horizontal tangents and 1 vertical tangent. So there are a couple of examples. Now, let's look at a couple of other things that come up, and we're going to talk about arc length and surface area with parametric equations. So let's do some arc length and surface area. Arc length and surface area of parametrics. All right, so here are the formulas. Arc length, lowercase s, okay, there's that one. It is equal to the integral from a to b of the square root of dx dt all squared. That's not the second derivative, that's the value of the derivative squared. And then dy dt all squared integrated with respect to t. That's also f prime of x squared g prime of x, or f prime of t squared g prime of t squared, if you have got those defined that way. Surface area is capital S, and that one is 2 pi. You might remember surface area formula from before at some point. So it's 2 pi, the value a to b, and then if you put g of t here, that's the y value, then we will be going about the x-axis. So let me write that down, but we've got dx dt squared plus dy dt squared dt. So this one is about x. If we make it 2 pi a to b, t values are a and b. If we put f of t, okay, so this is y, this one is x, so 2 pi x in a sense, and then we've got this, we've got square root of dx dt squared plus dy dt squared. So this is just the arc length, but then multiplied by either the x function or the y function. This one goes about y. And then times 2 pi to go around the axis. So let's try some examples with that. Here's an example. Let's find the arc length. So example, arc length of x equals 6t squared, y equals 2t cubed, and we're going from 1 to 4. All right? So the arc length formula, lowercase s. So s is equal to the integral from 1 to 4. This is all based on t. Square root of, now we've got to take the derivative of this, 12t, and square it. Got to take the derivative of this, 6t squared, and square it, and integrate with respect to t. So we get the integral from 1 to 4, square root of 144t squared plus 36t to the 4th dt. Now I need to try to simplify that so I can integrate. I've got a common factor of 36t squared in the radical. So I've got the integral from 1 to 4. I've got the square root of 36t squared that I'm going to factor out. If I take 36t squared out of this, I'm left with 4. 4 times 36 is 144. T squared is already taken out. Here I took the 36, but I've got a plus t squared. Then dt. So this is 1 to 4. Square root of 36 is 6, and this is t. This is square root of 4 plus t squared dt. Now this is not an inverse trig function that you've got to integrate. In fact, it's just simple substitution. Let u equal 4 plus t squared. Du equals 2t dt. Well, we've got to have 6t, so I'm going to go ahead and multiply by 3 here and 3 here. So I get 3 du equals 6t dt. And when t equals 1, u equals 4 plus 1 squared, or 5. When t equals 4, u equals 4 plus 4 squared, which is 20. So we're going from 5 to 20 in terms of u. So here is our function now. S is equal to, I'm going to put my work in here. 6t dt is equal to 3 du, so I'm going to put a 3 on the outside, put a du here. I'm going from 5 to 20. This is all based on u. And then here I've got a square root of u. So I'm going to call that u to the 1/2. So this is now pretty easy. We get 3 times u to the 3/2 times 2/3. Just integrate with the reverse power rule and go from 5 to 20. So here's what we've got. We've got 2 times 20 to the 3/2 minus 2 times 5 to the 3/2. Now that can be simplified a little bit. 20 is 4 times 5. So if I take 20 to the 3/2, I'm going to say that's 4. Let me get rid of that. To the 3/2, and then I've got 5 to the 3/2. Then minus 2 times 5 to the 3/2. So 4 to the 3/2, square root of 4 is 2. 2 cubed is 8. So 2 times 8 is 16. I've got 16 times 5 to the 3/2 minus 2 times 5 to the 3/2. So exact value would be 14 times 5 to the 3/2. So it turns out fairly nicely right there. And we've got an arc length. Let me change pages and do one more. We'll see what we can get out of this next one. I want to do a surface area problem. So let's find the surface area. X equals, so here's our example. X equals t, y equals 4 minus 2t. Let's take t from 0 to 2. And let's go about x. Doesn't really matter, but I'm just going to choose that one. So let's go about x. Now our formula to go about x is this. S is equal to 2 pi a to b f of t. And then we've got dx dt squared plus dy dt squared dt. Okay, so there's our formula, and I did the wrong one, didn't I? I've got to put g in here. Got the wrong one, g of t, excuse me for that. Here's what we've got to do. This is f and this is g. So s is equal to 2 pi. The integral from, in this case, 0 to 2. And then we've got to put g of t in there. So we've got 4 minus 2t. Then we've got to take the derivative of the x part squared. So derivative is 1. So 1 squared plus the derivative of this one squared. Derivative of this is minus 2 squared, and then dt. So this is not a terribly hard problem, but anyway, we get 2 pi, and then we've got the integral 0 to 2. We've got 4 minus 2t. This is 5, square root of 5, dt. So I'm going to just factor that out, and we've got square root of 5 times 2 pi. Then we've got this integral 0 to 2 of 4 minus 2t dt. So let me put the 2 in front. 2 square roots of 5 pi, and then we've got 4 integrated, so 4t, minus 2t integrated is t squared. Evaluate from 0 to 2. 2 square roots of 5 pi. Evaluate that at 2, so that would be 8 minus 4, and then minus 0 minus 0, putting 0 in, end up 8 minus 4 is 4, 4 times 2 is 8, square roots of 5 times pi. So there's our surface area. So there are a couple of examples. If you wanted to take that about y, you would just use the f of t rather than the g of t.